All right, guys, how you guys doing? So we're in chapter 12 today, looking at micrometers and also measuring devices we use out in the field quite a bit. Rulers, tape measures, using the English mics, metric mics, and the vernier dial caliper, which we use to measure internal and external components. After the lecture video, I'll be showing you some videos, demo videos on how to use some of these tools that I'll be pushing out there today. And I'll put them out there today and leave them open all the way until about probably Saturday night. That way you can take a look at them again. Of course, this is the last chapter that ends our Module 2 before we get into your Module 2 review and also the Module 2 assessment. And then on Monday at 1 o'clock in our Zoom meeting, we'll be looking at doing a review for the midterm exam already coming up for Modules 1 and 2 before we get into Module 3. So looking on page 98, we're looking at the ruler system. Of course, how many people know how to read a ruler and tape measure correctly? There's various types of ways that they come out with. Sometimes they come out with the smallest tick marks and being 30 seconds to 16ths on some rulers. So there's a couple of things that we need to look at, taking you back to school a little bit. You got a numerator, denominator. The numerator will always be an odd number. The denominator, which is the bottom number, will always be an even number. Okay, just to kind of remember that. On the page 98, it shows you that this ruler scale is on the 16th version of it. So you've got 1/16, 3/16, 5/16, 7/16, 9/16, 11, 13, and 15/16. And that's pretty much how it goes with those same numbers that I just told you about. We recognize those in sockets and we recognize them in wrenches because those are the common sizes that we use, and that's where they get it from. They get it from actually measuring the socket material with a tape measure or ruler, and then cutting it perfectly to achieve those type of measurements. And then we've got the next scale below it, a little tick mark, which is the 1/8 mark. 1/8 would be 1/8, 3/8, 5/8, 7/8. And then we've got the quarter, a little bit longer line from that one, so it's 1/4, 1/2 inch, and then 3/4. And then of course we've got the 1 inch at the end. So typically, whatever number passes it, if there's a 1 and then it comes to a tick mark, we need to be able to identify that tick mark. There's several instances where we may have to do some measurements in the automotive industry, with brakes, or measuring brake drums, measuring an engine repair. We do a lot of measurements, precise measurements with micrometers, which we're going to be getting into right now. But measuring curb height, ride height for suspension, we got to learn how to read a tape measure. Besides tape measurement reading, is critical for almost any type of construction field out there. So everything's got to be measured, cut precisely, whether you're woodworking or welding. Automotive, we use that. So it's important that we know how to use learn to be able to identify the different tick marks on a ruler or tape measure. And I've got that in my PowerPoint presentation too. If you look at chapter 12, overview of measurements and systems, I have that on there. So it gives you plenty of time to kind of look at that. And that's where we're at right there. Micrometers, though, here's a couple of things that we need to look at on that. The components of a micrometer are kind of important. The anvil, you got the measuring faces, and then we got the spindle that's going to move in and out. Of course, we have a lock nut that locks our reading in place so we don't move it by accident. The sleeve is another internal measurement reading that we can look at graduations from that. Then we got our thimble, which we're going to turn. Then we got our ratchet stop, and what our ratchet stop does for us there is when we actually open the micrometer and measure something, when you hook the ratchet stop, when it clicks, that's when you stop. You don't go any further than that. Okay, that's what they call a ratchet stop. On the sleeve, we're looking at the different types of measurement readings on that. Just understand that on the sleeve, we're going in increments of 25 thousandths. So the book doesn't have a good little view on that one, but on the on the, well, it's okay. It's not really good, but the one that I really have is really good. That's on my PowerPoint presentation. Kind of shows you that 0, then you got a little tick mark, that's 25 thousandths, then a little bit bigger tick mark, which is 50 thousandths. The next one is 75 thousandths, and then when you get to the 1, it's 0.100 thousandths, and that's written and expressed by 0.100. So typically, like I said, if you look at the PowerPoint, it have a pretty good analogy of how that works with the reference to with the numbers there that are on the sleeve end. So typically we would like to go ahead and get you guys in the lab to be able to do this. But on my PowerPoint, on slide 14, it kind of shows you there a reading of a micrometer up close, so that way you get a chance to see it up close. On the metric side of it, we do have numbers, and actually on the metric side of it, it's pretty much easier and simpler to read. Metric's always the smaller divisional numbers on that one, because we go about 25, 24 on the English mic, and then we're going to go up to about 55, 59 on metric. So we're looking at closer tolerances. So when we look at that, guys, understand that on a metric mic, we have graduations of 0, and then the top 0 on the top, and then the bottom scale, you got small little tick marks that go in the bottom of it. All of those are in 0.5, always in 0.5. So on the top number, and this is on slide 15 of 26 in my PowerPoint. It's a very good view of what it looks like there. You got from 0, right next to 0, it's 1, 2, 3, 4, 5. Okay, so there's a good illustration of how that works right there. So you got the 5, and then you got a tick mark on the bottom, which is 0.5, and then you're gonna add 25, 26, 27, 28 to that. So that will come out to 5.78 millimeters. Okay, 5.78 millimeters. The key on this one is to make sure that you line up the decimal marks on top of each other. So you need to know the range first of your particular micrometer. In an English mic, it's typically 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. On metric mics, you're looking at 0 to 10, 25 to 50, 50 to 75, 75 to 100 on the range. So, and you'll see that as soon as you open up the micrometer, and it'll show you there when you look at that, guys. So on this one, on page 15 of 26 on my PowerPoint, I'm looking at it right now, and you can look at that on your module section on the chapter 12 overview of measurement tools and systems. Shows you a very good illustration of a metric micrometer being used and measuring what that reading is. Typically in the class, in the lab, of course, we would be giving the mics out to you guys for you guys to use, so that way you'll know how to use the mic. But this is what we got to do for right now, guys. On page 101, we're looking at, on this one here, some of the ways we can use a micrometer to measure camshaft lobe. We also do have another thing called a telescoping gauge, where we can measure internal clearances like the cylinder wall area, lifter bore area, camshaft bearing area. So typically it looks like a T. It's on page 101 right there. You can see a couple of demos on that, or what it looks like there, where the technician is miking something inside and it's spring loaded. So when you open those guys up, you go inside the bore, you open up and go counterclockwise, and then the spring loaded tanks push out the levers of both ends. And when it does that, then you tighten it up, then you pull it out, and then you get your micrometer and mic over it. So that way you can see what that reading is and compare it to specifications, of course. In English mics, when we're usually measuring type of internal or external components within the engine system, we're looking at a very, very close tolerance of 10 thousandths of an inch tolerance. So, you know, typically when you see a micrometer reading and the line intersecting the sleeve and the thimble do not intersect, we have to go with the bottom number first, because that number has already been past the 0. So, and then on the back side of it, and I'm I'll demo this in the lab part, but on the back side, you're gonna flip the frame and you'll see some numbers from 0 to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 0 at the end. That's the veneer side. That's the 10,000 scale. So on that particular one, you know, you'll get your reading, your range, you'll get your reading from your sleeve, your thimble, and then we're gonna flip the frame, and that last number at the end, you're just gonna drop it, because that's on a 10,000 scale. And like I said, I'll show you that in another video when I do my demo for you guys. That way you get a better understanding of what that looks like when you typically do it. The other thing that we look at, guys, of course, we have feeler gauges, we got straight edges. Feeler gauges are thickness gauges, they call them. It measures small clearances. We can use those to measure when we're doing valve adjustments like in the injury repair class, or we're doing piston ring end gap. On page 103 on figure 1217 shows you a typical way of checking ring end gap, and plus we do is a straight edge on it where we can demo and see we got warpage in the cylinder head. There's a couple of videos on that I've done in my injury repair class that I'll probably share with this class regarding that. That way you can see the measurements that I did for that one, which coincides with what we're doing here, guys. The other thing that we do use as well is a vernier dial caliper. And a vernier dial caliper is on page 102 at the top. And like I said, I've got it in my PowerPoints as well. But on my vernier dial caliper, we look at measuring acute clearances. We do that when we're measuring on page 20 of 26 on a PowerPoint. Shows you the vernier dial caliper on that one. So on this one, we're looking at a range scale, typically from 1 to 6 inches on the blade end. And then we got the dial in, and each of those, like the book, this one has 2 thousandths of an inch for each little tick mark. On the one that I have that you would be able to use in the classroom, it's in 1 thousandths. So you would take that reading on the typical side of the blade on the bottom, and if it's a 1, and then you've got numbers on the bottom that range anywhere between 1 and 9, those would be in like a tenth of a decimal. So you're gonna go 0.1, 0.2, 0.3, 0.4, all the way to 0.9, okay, before you get to the next whole number. So in the typical range where we have 1, 2, 3, 4, 5, 6, that's gonna be your standard reading there. So if it's at 5, it's 5 inches. And if you've got the blade going next to the side of where the jaws is, on the inside part where the dial is, then you would put that number as a 0.5, 0.5. And then we would look at the last thing we look at is the dial and see where that guy's gonna be at. And then we would see, you count the numbers, and like I said, it's on page 102. This is a pretty good illustration that I like to see. It's got it past 36. So that's 0.36 thousandths, because each one of those lines is 2 thousandths. So 2 thousandths is written as 0.002. Okay, that's in the thousand scale. Of course, you got the 10 scale, 0.1, 100 scale, 0.01, and 1,000 scale, 0.0001. And then you got the 10,000 scale where you got 0.00001, which would be 1/10,000ths, okay? And that's what we're looking at right there on small clearances. Like I said, feeler gauges are another thing that we use. You know, they were even used to measure spark plugs. So at one time, but valve adjustments, straight edge measurements, we use it quite a bit in my injury repair class. A lot of miking with feeler gauges to be used and done. So those are a couple of things that we'll look at. like I said, I will be doing some video demos that I'll be sending my module for you guys to be able to look at. And then, like I said, we look out for that today, because I'll have that up there for you today. Tomorrow, like I said, that's why I want to do this on today for chapter 12. But tomorrow we'll be looking at doing the review for the assessment. Okay, you'll have the assessment open up this coming weekend until Monday. So be on the lookout for that. That'll be your module 2 assessment. Okay, and again, this is going to be a written assessment, so I'll cover that with you guys really good for tomorrow, and leave that open for a while, so that way you can look at it over and over again, and then you'll be able to take your lab 2 assessment on that particular I think Sunday and Monday. I think I have it open for, so kind of look out for that. In the meantime, stay safe out there. Be careful. I know the governor put it, and the mayor had got word to help increase the direction to wear face masks wherever you go now. So kind of be careful with that. And I just want you guys to be safe. And if you have any questions, just email me. All right, you guys take care. Bye.